Hello everyone, and welcome to Biopedia. In the biblical tradition, the human population of the world starts out with just two people, Adam and Eve. According to Anglo-Irish priest James Ussher, who wrote a chronology of the world in the 17th century, time began in the evening of the 23rd of October 4004 BCE. Humans came along on Friday the 28th of October 4004 BCE. As we discussed a few episodes ago on the podcast, we see this kind of tradition in more than one place. For example, in Norse mythology, we start the world with Ask and Embla, whom the gods find on a plain. Once the world is set to end in Ragnarok, there will once again only be two people in this new world, namely Lif and Lifthrasir. The pair will survive the end of the world by hiding in a tree and are destined to start humanity again. But my footnotes to the Poetic Edda note that we do not know anything else about them. Over in Greek mythology, Zeus destroys the world via a flood after a man called Lycaon tries to serve him human flesh to test if he is an all-knowing god, and only two righteous people survive, Deucalion and Pyrrha. Again, we end up with a man and a woman. Incidentally, these two are both cousins and husband and wife. They end up reforming humanity by throwing stones over their shoulders, which are transformed into people by divine will. The pair also have biological children together, but this first mechanism is definitely one of the more unusual ways of forming or reforming humanity. All of this got me thinking. Would it be hypothetically possible for two people to recreate humanity if it was just them left? As a hypothetical scenario which could cause this, let's focus on a phenomenon exemplified by the asteroid 2024 YR4. NASA writes on its website that this asteroid was once thought to have a small percentage chance of striking the Earth on December 22nd, 2032. However, it is now thought to pose no statistically significant threat. So, let's go for something like this happening to end humanity. We'd have to make this asteroid quite a bit bigger, as 2024 YR4 is only the size of a building, and we would need something 100 kilometers across to make Earth an uninhabitable mess and threaten humanity. Now, a paper published in 2022 in the journal Futures says that the probability of something massive hitting the Earth in the next 100 years, with a short warning time, is 2.2 times 10 to the minus 12. In other words, fairly unlikely. Across the next billion years, the probability of a massive impact is between 3 and 30%. Now, although the paper thinks moving a massive asteroid out of the danger zone is not possible, and everything except extremophile life would die out, some humans might survive underground. Moreover, this paper thinks that spreading out to other planets is a solution to this issue, and we would have enough time to do so before something like this would happen. And since, to cite a University of New South Wales webpage from 2021, we will likely have a Martian colony by 2050, we are currently increasing our odds of survival a lot. However, this message of hope is just boring. We want to find out what happens if there are only two people left alive. So, let's say a massive asteroid strikes the Earth and for some reason we don't see it coming. If there is a Martian or lunar colony in our hypothetical example, let's say that they would be unable to survive without help from the home planet and die out too. Either way, however long this scenario takes, we are left with just two people in this hypothetical 2032. Let's say that they were the only two people surviving underground, as per our 2021 paper. Unlikely, I know, but still, it's the end goal that we're looking for. So, here we are with just two people. What now? We're going to start with some basic assumptions. For the purposes of this scenario, we are going to say that these two people are genetically unrelated and are close enough they can find each other in their wanderings around the world. After all, if one were in the USA and one were in Afghanistan or Japan, the chances of them randomly finding each other would be very slim. So we're going to say that they somehow end up finding each other relatively soon after the impact. Now, I allowed those close to me a chance in naming these two for our scenario, so meet Cornelius and Cornelia. We are also going to say that, when they run into each other, Cornelius and Cornelia are at the younger end of the age scale, let's say 18 years old, to avoid any problematic implications. In fact, let's say they run into each other on their joint 18th birthday to make our subsequent calculations easier. We are also going to say they are both healthy and conform to the average in terms of things like lifespan, age at which they can reproduce, etc. As a final assumption, let's say they are agreed they're going to repopulate the world, as otherwise our scenario sort of falls apart. So, let's discuss how many kids they could have. They are trying to repopulate the world, so we're going to assume we're going for some sort of maximum here. Gestation time is about 40 weeks in humans. Now, the World Health Organization recommends leaving about 24 months, so 2 years, between births to minimize adverse outcomes. Elsewhere, it's generally recommended to leave a gap of about a year between pregnancies. Leaving only 6 months for mothers over the age of 35 increases the risk of death or serious impacts to the mother. A spacing of 12 months between pregnancies results in a small increase in the risk of earlier births and smaller babies, while 18 months leaves the least risk. Next, let's talk menopause. One paper uses an average of 50 when discussing hypothetical fraction of age spent in the menopause in UK women, in terms of the onset of menopause. NHS Inform cites the average age as 51 for UK women, and the WHO states that its onset occurs between 45 and 55 years of age in most women. Granted, studies cite factors such as smoking, depression history, losing an ovary while relatively young, body mass index, and how many pregnancies you've had, which can influence when the menopause begins. However, for simplicity's sake, we're going to take 50 years old as the age when our hypothetical woman will go through the menopause and will stop ovulating. So, taking all this into consideration, the pair will have around 32 years in which they can produce children. If we leave gaps of 18 months, as we talked about above, or about 78 weeks, this means pregnancy plus gap gives us 118 weeks. In other words, you have 118 weeks between the start of one pregnancy and the start of another, assuming a fairly constant rate. 32 years translates into about 1,664 weeks. Dividing 1,664 by 118 gives us 14 pregnancies. Now, if we were to decrease the gap between pregnancies to 12 months, or 52 weeks, we would get 18 pregnancies total. So let's go with a medium range and say they end up with 16 pregnancies altogether. This kind of maths will also apply to all subsequent generations as a baseline for simplicity's sake. We're also going to assume that there are no twins or multiple births for now. I was going to dive into the probability that this could happen, but ran into a minefield when it came to a concept called Helen's Law and decided it was best left as a story for another time. I will also assume that the ratio of boys to girls has ended up 50-50, as the ratio of sex chromosomes in sperm would suggest. So, in our scenario, by the year 2064, when we've decided Cornelia's menopause sets in, the pair have 8 boys and 8 girls, each 118 weeks older than the last. The total world population is now 18. However, this is where we're going to leave it for today's episode. This is because, if we were to see this scenario through all the way to its conclusion today, we would end up with a scenario which is far too long for a regular Biopedia episode. We will pick our story up again with part 2 later down the line. Until then, and until next time, thank you all for listening. Feel free to get in touch with the show's email address if you have any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.